Hello everyone, welcome to the next session on ANSYS Workbench tutorials. In this session, we will analyze the soda can for its internal pressure analysis. We will be using the explicit dynamics module for it. We will start by double-clicking on explicit dynamics. First, we'll go to engineering data and double-click. You should click on engineering data sources. Here, go to explicit materials. In explicit materials, we will be using aluminium as the material. So I'll bookmark the aluminium material. You can click on engineering data sources instead of searching in the list. You will see here aluminium has been bookmarked. Next, I'll go to project and update the project. Then I'll go to geometry and right click and I'll import the geometry directly. Then I'll go to model and double click. Here we'll go to geometry and click on this plus sign, and then I'll go to the soda can geometry. The first one I'll select as aluminium material, and for the next one, that is the body, also I'll give the material as aluminium. Then I'll go to mesh and I'm going to generate the default sizing of mesh itself. I'll click on generate. So you can see here the meshing has been done. Now I'm going to use only the body, so I'll remove this top portion first and I'll suppress here. Then I'll go to explicit dynamics A5. Here we'll first go to analysis settings and give the end time as 0.001 second. Then I'll right click here and insert fix support. The bottom portion is what I'm going to fix and apply here. Next, I'm going to apply pressure. So I'll select the internal portions where the liquid is going to apply pressure. We are trying to find out what is the bursting pressure on this aluminium soda can. So here I'll give the value as 1.5 megapascal. Then I'll right click and insert force. I'll select face option over here, you can see. Then I'll select this top portion. Click on apply. I'll change define by from vector to component, and along the y-axis, if you align the body, you can see this is the y-axis, that is the y direction. So here I'll apply a force in the downward direction of minus 50 Newton. Then I'll go to solution, right click, insert deformation total. I will also insert the deformation directional, which is along the y-axis. I also want to see the strain equivalent and the stress equivalent. Then I'll go to solution and I'm going to solve. Now when you solve, you can also unsuppress this top portion, the top lid which you had suppressed. So you can just go for unsuppressed body. You have this present now. Then you go to solution and click on solve. The solution will take quite a lot of time, so you need to wait patiently for the version to solve the solution for you. It will also depend on the processing speed of your desktop or laptop that you are using. So you can see the result is obtained. So the first thing we'll go for is the total deformation. You can see here, this is the total deformation over the entire body. The value is 0.3796 mm. Maximum, minimum is 0. So we can just animate and check this result over here. Click on animation. Now we are having the elements over the body. If you don't want to see the elements, you can go to edges and click over here and select no wireframe. So again, if you click on play, you can see the variation of colors over the body. Then we have the result of directional deformation. Here the maximum value is 0.00164 along the y-axis and minimum is minus 0.37588. So you can again play and check this value. Then we have the value of strain. Maximum is 0.003265. Minimum is 0 over here. If you want to see where it is max and min, you can just click on max min. You can see. If you don't want to see this tag of max min, just click on max min once again. Then we have the value of stress. The maximum stress obtained is 230.35 megapascal. Minimum is 0 over this body. You can again animate and see the variation of stress over this body. Now this result is obtained for a pressure of 1.5 megapascal over this body. You can see I've given this value. Now if I change this value to a higher one, you can change for various values. I will check directly for 5 megapascal. I want to show you the result for 5 megapascal. So I'll go to solution once again and solve. So the result is obtained. We will click on total deformation. So you can see here when I apply 5 megapascal as the internal pressure, this is the situation of the soda can. So we'll just click on animation and we'll see how it is going to completely burst. So this is nothing but the internal pressure applied and the bursting pressure has been obtained. Now the maximum value of total deformation is 200.74 mm over this body. Minimum is 0 obviously. Then we'll go for the directional deformation. Here also the bursting effect can be seen. You can see the maximum value of directional deformation is 62.735 mm along the y-axis. Minimum is minus 106.81 mm. Now you can just see how it is going to burst. And also the color change over this body. Next is the strain, which is maximum of 0.004 and minimum of 0. And the stress now is 290 megapascal, minimum is 0. So this analysis actually tells you how you can analyze the internal pressure, which is maximum that can be held by this soda can. As you are aware, the soda can generally is going to have an aerated drink. The soda is actually aerated, which means it's going to contain some carbon dioxide. So it is possible that it can burst open. So if it shouldn't burst open, what should be the maximum pressure created by this liquid on this can? And if at all it exceeds that pressure, you can see this kind of bursting effect. So with this, I end the session. I hope you have understood the internal pressure analysis on the soda can. If you have any doubt, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.